Example 4 here says determine whether each statement is true or false. Again, let's look at this. The first statement is the set 1, 3, 5 is a subset of the set 1, 5, 9. Remember, subset means everything in the left is in the right. So analyze if that's a true statement. I'm seeing that that statement is false. The reason being is, how about the number 3 right here? So if I call this the set A and I call this the set B, I could say 3 is an element of A, but 3 is not an element of B. Remember, anytime you want to say that two things are not subsets, you need to find something in the first set that is not in the second set. And we were able to, the number 3. Next one, part B, says the set of counting numbers is a subset of the natural numbers. Well, let's think about counting numbers. Counting numbers and natural numbers, those are the same thing. And if we know they're the same thing, we know A is a subset of A for everything, so that has to be true. A set is a subset of itself. Part C, the empty set is a subset of the universal set. Again, we know that that is a true statement. The empty set is a subset of all sets. So let's write that as our justification. The empty set is a subset of all sets. Okay, and then how about negative 6, 0, and 11 is a subset of the integers. So the question is, are negative 6, 0, and 11 all integers? Integers are positive and negative numbers, so that is true. These are all integers. Okay. So, Venn diagrams. If you remember Venn diagrams, you can read this paragraph and it tells you essentially what you have to do is, just as it's so important, you can't talk about a complement of a set without a universal set. In a Venn diagram, the most important part is drawing the box. That box represents the universal set. So this is the stuff that we're talking about, okay? So we have two regions of a Venn diagram in this picture. We have the set A. Anything inside the blue circle is a part of A. Anything outside the blue circle, which would be the area that I'm shading in red right now, that would be A complement. So A complement is anything inside the universe that is not in the set A. So this is a Venn diagram is a nice visual representation at looking at members of sets and complements of sets. So this poses a question. It says, what is A complement? Well, we know A complement is the red area. So what's the complement of the red area? It's everything that's not in the red area, which is the blue area, and we know the blue area is A. So A complement is equal to A. Let's look at a proper subset. What's the difference between a regular subset and what's called a proper subset? Here's the difference right here. Proper subset, it looks like the same symbol, a sideways U, except it doesn't have that equal sign on there. And so what I like to think of it is a subset is like less than or equal to. A proper subset is like strictly less than. So like if I said what are the integers, or sorry, whole numbers less than 3, you would only say the numbers 0, 1, and 2. If I said what are the whole numbers less than or equal to 3, you could actually include that number 3, right? So it'd be 0, 1, 2, or 3. So the question is, can you include the whole set or not? Well, with subsets, it can be equal. With proper subsets, it cannot be equal. So it's a proper subset if it's a subset. So you still have everything in A is in B, but you just have one subtle difference. They cannot be equal. So to show that something's a proper subset, state that everything in A is in B, but they are not equal. So you have to state two things. The first thing you state is, one sec, let me get my pen. Everything in A is in B. But the second thing that you have to state, which would have said that it's a subset, the second thing that you have to do is say they are not equal. So that's how you prove proper subsets. It says to illustrate the difference between a subset and a proper subset, consider the set A, which is the letters A and B, set capital B, which is the letters A, B, and C, the set capital C, which is the set A, B, and C. It says A is a subset of C. Well, that's true because everything in A is in C. And it says A is a proper subset of C, and that's true because everything in A is in C, and they're not equal. Okay? So you have to say everything in A is in C, and they're not equal. So that makes it a proper subset. And then it says B is a subset of C. Well, they're equal, so that's true. Everything in B is in C. And it says B is not a proper subset of C. Why is B not a proper subset of C? Is because not only are they subsets, everything in B is in C, but they are equal. So that makes it not a proper subset.